Hi there, I'm Michaela, the On-Farm Network Research Assistant. In this video, we will go over the 2023 results from our pea fungicide trials. Before getting into the trials, I'd like to provide some context and background on different pea diseases that are infecting your crops in Manitoba and what diseases we're managing with fungicide applications. Mycosphaerella blight, also called Ascochyta blight, is our main disease target of fungicides, so we'll look at its life cycle in a bit more detail. It overwinters in soil, on crop residues, and on infected seed. In early summer, airborne ascospores are released and may travel long distances by wind to infect peas. Initial infections commonly appear as small dark freckles near the soil surface or as these ring lesions in the mid-canopy. Most often, early symptoms appear as these freckles on the lower leaves. Over summer, these lesions expand and secondary infections by rain splash and high humidity move the infection up the crop canopy. And then after harvest, pea residue, soil, and seed can carry on the disease life cycle. Fungicides are applied around flowering when these initial infection symptoms are popping up to limit disease spread up to the canopy. While Mycosphaerella is the main disease target, there are other diseases infecting peas. Mycosphaerella blight and bacterial blight can commonly be confused in the field. This can be troubling since bacterial blight, being a bacterial disease, will not be controlled by fungicides. At fungicide timing around flowering, what we're scouting for in peas are these small dark freckles on the lower leaves. Since it's coming up from the soil and residue, we're looking at the leaves nearest the soil surface in the bottom of the canopy. Bacterial blight infections following leaf damage from storms or heavy rains, so we more often find this disease in the mid to upper canopy. Leaf lesions are angular since they follow leaf veins. Edges of the lesions will look water-soaked and later on they'll progress into this window pane type appearance. Less frequent foliar diseases that we see in peas are downy mildew and white mold. With downy mildew, the top of the leaf will be pale green, and when you flip that leaf over, you might find these fuzzy gray growths. For white mold, similar to with other broadleaf crops, you'll find pale, wilted patches of a crop with hard black sclerotia bodies. White mold isn't as prevalent in peas as it is with other broadleaf crops since there's generally less leaf material in our semi-leafless pea varieties. So with that introduction, let's talk about on-farm trials comparing fungicide strategies. We have two trial types, the first comparing a single application of fungicide at flowering versus none, and the second comparing a single app to two apps. We'll talk about these two separately. It's been more common in drier years for farmers to compare single versus none, asking the question, do I need a fungicide application in a dry year? And then in wetter years, it's been more common to compare a single versus double application, asking the question, do I need that second application to protect and maintain pea yield? In 2023, we had 7 single fungicide applications and 2 double fungicide application trials. First, the single versus none trials. Here we're looking to evaluate the impacts of a single application versus none in peas. Will a fungicide application reduce Mycosphaerella blight disease pressure? And will it improve yield and provide a return on investment? Of these trials, fungicide applications were made at R1 to R2, which is early to full flower. On average, that fell on June 28th. Products used are in this table on the right. This year it was Delero, Diox, and ReviPro. Average pea seeding rates across these trials was 372,000 seeds per acre, and the average established pea plant stands were 278,000 plants per acre, or about 6.5 plants per square foot. All of these trials were grown on rows 10 inches or narrower. Here's the percent normal rainfall for these trials leading up to flowering in June and following application in July. Each of these paired bars is an individual trial, with a lighter colored bar on the left representing June rainfall and the bar on the right is July rainfall. At each trial in 2023, June rainfall was less than 80% of normal, and July rainfall was less than 70% of normal at all trials. Disease pressure was evaluated in every strip of the fungicide trial. Incidence and severity ratings are taken for Mycosphaera blight, both foliar and stem infections, and white mold. Downy mildew and rust presence are also noted. Starting with Mycosphaera blight, foliar infections, for each trial we have incidence or the percent of plants infected on the left and severity of the infection on the right. For these paired bars, the lighter colored bar on the left is peas without a fungicide application, and the right darker bar is peas with a single application of fungicide. So a single application of fungicide reduced the amount of plants with foliar symptoms at 2 trials, but only reducing disease incidence by 3%. The severity of infection was reduced at 6 trials with a fungicide application. Fungicide applications limited the spread of disease further up the plant canopy at these trials. Stem infections were rated separately, and that's what's shown here for each trial with the percent of plants infected. Stem infections were less common than foliar infections. A fungicide application reduced the percent of plants with stem infections at 6 of these trials. This year, we tested some additional things like group 11 fungicide-resistant seed-borne Ascochyta. For group 11 resistance, we sampled 10 pea plants with visible symptoms from untreated areas of the field and tested them to determine the proportion of the disease population that was resistant to group 11 fungicides. The greatest amount of resistance was found in central Manitoba at 4.8%. For seed-borne Ascochyta, seed samples were submitted after harvest for disease testing to assess if the fungicide had an impact on the amount of seed infected with Ascochyta. A fungicide application reduced the amount of seed infected at 5 out of 7 of these trials in 2023. Now let's look at the yield results. Each of these paired bars is a trial, and the number above the pair is the yield difference between no fungicide on the left and a single app on the right. A single application of fungicide at flowering significantly improved pea yields at 3 out of the 7 trials, the 3 which are shown on your screen right now, improving yield by 2.8 to 12.6 bushels per acre. At these significant sites, did an application of fungicide pay for itself, and were the yield increases large enough to cover the cost of the fungicide product? Well, assuming a fungicide cost of $23 an acre and a pea sell price of $10 a bushel, a yield improvement of more than 2.3 bushels was needed to improve profitability, which happened at all 3 of these significant sites. So in total, that means that 43% of the time, a single fungicide application provided an economic yield increase in peas. So in summary, comparing one application to none in peas, we saw a yield response 43% of the time, all of which were economically beneficial. Fungicides are not a one-size-fits-all game. Return on investment is going to come down to how early plants are infected with Mycosphaera and if growing conditions are conducive for disease to develop up the plant canopy. We'll talk more about making fungicide decisions after we talk about 1 app versus 2 next. The second fungicide trial type is comparing 2 applications of fungicide versus 1, also called the double versus single app. The questions we're looking to answer are, will a second application reduce disease pressure, and will it provide a return on investment? In 2023, we had 2 trials which compared 2 applications of foliar fungicide versus a single application. The distribution of this trial type is on the map here on the right. As you can see, both of these trials were up north in the Swan area. We typically see these trials in fields that had persistent leaf wetness and more moisture in the growing season. The 2 trials that did double versus single application are P fungicide 09 and P fungicide 10. So in terms of application timing, the first application was generally applied at early to full flower, which occurred on June 26th and 27th for these trials. The second application was applied at R3 during flat pod stages at 10 to 14 days later, so July 6th and July 7th. Both of these trials rotated to a different product for the second application, and products used were Cotegra, Delero, Diax, and Mirvisneo. For P. fungicide 9, seeding rate was 300 pounds an acre, which grew a plant stand of 444,000 plants per acre on 10-inch rows. P. fungicide 10 had a seeding rate of 210 pounds an acre, which grew a plant stand of 258,000 plants per acre on 7.5-inch rows. Here's percent normal rainfall for June and July at each individual trial. June and July rainfall were below normal at each trial. At PF09, we had close to 70% of normal June rainfall, but less than 20% July normal rainfall. And at P. fungicide 10, we had just below 45% normal June rainfall and nearly no July rainfall. Disease ratings were the same as described earlier. We're evaluating Mycosphaerella blight and white mold while making note of downy mildew or rust disease pressure. We're rating both incidence and severity of Mycosphaerella and white mold. Starting with Mycosphaerella foliar infections, with incidence on the left and severity on the right, the percent of plants with foliar infections of Mycosphaerella blight didn't change with the second application of fungicide at P. fungicide 09, but the incidence and severity of infection was reduced at P. fungicide 10 by 22 and 12% respectively. In terms of stem infections, a second application of fungicide did reduce the percent of plants with stem infections at P. fungicide 10. Incidence of stem disease at P. fungicide 9 actually went up a little bit, but not significantly. A second foliar fungicide had no influence on yield in 2023, and thus there was a profit lost equal to the cost of fungicide product and application. So if you're interested in learning more about these results, every trial result is available on the On-Farm Network database, available at manitobapulse.ca or by following this QR code. If you're interested in participating in a trial, please contact Chris, the On-Farm Network agronomist. Thanks for listening today. I've been Michaela, the On-Farm Network Research Assistant. You can find more information on our website or by following us here on social media.